Alright, so this is going to be a hazard assessment on the volcano Vatnafjoll in Iceland. I'm not really 100% sure how to pronounce it, but here we go. So in order to fully understand the volcanic history of Vatnafjoll, Iceland's volcanic history also needs to be considered. Iceland is the largest island sitting on an oceanic ridge. The volcanism in Iceland formed from the spreading of the mid-Atlantic ridge, and the geologic activity and structures is a direct result of the diverging plates and hotspot. The tectonic activity creating Iceland started around 25 million years ago. Fissures, shield volcanoes, and composite volcanoes are common in Iceland because of the rift zones. The fissures in Iceland are normally parallel to the rift zones. Most volcanoes on Iceland are inside the diverging plate boundary and experience large amounts of tensile stress from the spreading plate, causing volcanic chains. The spreading rate of this plate is about 1.8 centimeters a year. The plate boundary that spreads the Eurasian plate and the North American plate contain the most volcanic activity, and this happens to be where the volcano Vatnafjoll lies. The Vatnafjoll volcanic system is 40 kilometers long and 9 kilometers wide and contains many basaltic craters and fissures. This volcanic system is one of Iceland's most active throughout history and has had many fissures that form every 1,000 years. Iceland is very volcanically active and has 30 active volcanic systems. 16 of these systems have erupted during human history, which is very active, geologically speaking. All of these systems are organized into zones. The volcanic zones are the Reykjanes zone, or also known as the Reykjanes volcanic belt, the South Icelandic seismic zone, the West volcanic zone, the North volcanic zone, the Tijorns fracture zone, and East volcanic zone, which this presentation is going to focus on. Volcanoes in the East volcanic zone include, and I do not know how to pronounce any of these, Eyjafjallajökull, Katla, Hekla, Vatnafjoll, Torfjallajökull, and Grímsvötn, Þórdinja, and Hagangur. The most active volcanic system lie within the East volcanic zone, and they are the Katla, Hekla, Grímsvötn, and Mývatn volcanic systems. The East volcanic zone is the most active and has accounted for over 80% of eruptions in Iceland, and has produced over half of the erupted material out of all the zones. A hazard assessment is going to be made on all the volcanoes on the volcanoes in the East volcanic zone and the volcanic system Vatnafjoll. This volcano is a part of the Hekla Vatnafjoll system. All of the volcanoes in the East volcanic zone play an important role in understanding Vatnafjoll volcanism. In order to predict the possible hazard of Vatnafjoll, the history of the volcano and its eruptions must be analyzed. This volcano is a fissure vent system that is southeast of Hekla. The history and geologic activity around Vatnafjoll can provide insight to the volcanic activity of the volcano specifically. Hekla's volcanic history needs to be analyzed because they are a part of the same system and can provide a lot of great insight. Hekla has been very active throughout history. Because of its activity and high explosive eruptions, it was deemed the gateway to hell during the Middle Ages. This volcano is also very unpredictable and tends to erupt every 120 years. Throughout human history, it has had 4 major eruptions that have been recorded. In the year 1104, the volcanic eruption was recorded to be the most explosive after being dormant for about 250 years. This data was gathered based on brief descriptions of the volcanic eruption and the magnitude of material that was ejected from the volcano to the surrounding area. Over half of Iceland was covered with large volcanic material. Data on these eruptions have been gathered from historical texts called the Icelandic Annals. Unfortunately, these early eruptions were not detailed and only claimed that eruptions had taken place. Between 1104 and 1300, 3 small eruptions took place and formed the Vatnafjoll lava flow on the west side of Hekla. However, the later eruptions became more detailed, and for the eruption of the 1300s, the Icelandic Annals said that coming up a fire in Mount Hekla with great sandfalls and with such great crash when rocks struck together in the fire that they heard over nearly the whole country. It was so dark, and while the sandfall was at its height, that it was not light enough to read in those churches situated near the source of the fire. Great famine, great loss of stock, both sheep and cattle, so that between the fitting days to the feast of St. Peter, which was early May 1st to August, Salkot alone lost 80 cattle. This volcanic eruption was very large and lasted a whole year. It is estimated that the Selsundrum lava flow may have caused this eruption. Hekla has also had major eruptions in the years 1510, 1597, 1693, 1766, and 1845, and they were more destructive and very explosive than the 1104 eruption. This is because there were more habitants during these times, and eruptions destroyed more livestock, towns, and killed a lot of people. Each eruption has thrown millions and millions and tons of tephra, covering the surrounding area for miles. The amount of magma that has been estimated to be produced from these eruptions adds to about 200 million tons in a year. Tephra is the rock fragments and other materials ejected during the volcanic eruptions. The last recorded eruption of Hekla was in early 2000. However, this eruption was not nearly as catastrophic as its past eruptions. In fact, this eruption was very minor. When looking specifically at the type of eruptions Hekla has had throughout its history, most of them have been fissure eruptions and Plinian eruptions. Plinian eruptions are a type of volcanic eruptions that is one of the most extreme and powerful out of all the different types of volcanic eruptions. There is so much force from these eruptions that magma and ash can be ejected up to 35 miles into the air at hundreds of miles a second. It then spreads out, dispersing the materials for hundreds of miles. These eruptions are very loud and can be heard from thousands of miles away. When trying to understand how explosive and dangerous the Vatnafjoll volcano could be, looking at the magnitude of the magma chamber in this area can be insightful. The volcanic system of Iceland has many double magma chambers, where the rift zone composite volcanoes magma pull from the shallow magma chamber. This magma chamber then pulls from a larger source beneath the crust of the magma, as given the magma reservoir. Rock analysis and general composition of the magma has given some insight to how large the magma chamber can be. The basaltic andesite to Rayleigh composite volcanoes are estimated to spew over 25 cubic kilometers during just one eruption, and because of this, the magma chamber is estimated to be very large. Several studies on rift zone central volcanoes in Iceland suggest that there are large reservoirs that fill into all of the volcanic systems. Not only is the magma amount a helpful tool when observing the volcano's potential hazard, but so is its composition. The composition of the magma can give great insight to the type of eruption that might take place. However, the volcanism in Iceland is very unique, and each eruption has had different compositions and range from more mafic to less mafic in composition. Because of this, Iceland's eruptions can be a mixture of different types of eruptions. For example, mafic magmas would be expected to be less viscous and more effusive and not that explosive as compared to more felsic magmas, which would be explosive and typically found with composite-type volcanoes. Because of the ranging composition in these magmas, the volcanism in Iceland varies from being explosive, non-explosive, or a mixture of both. This adds a bit of unpredictability with the eruptions that take place. Vatnafjoll is a 25-mile-long, 6-mile-wide basaltic fissure vent that is connected to the composite volcano Hekla. Fissure vents are most commonly associated with composite and chilled volcanoes and cause large lava channels. This fissure is southeast of Hekla and has been a very active volcano historically. It has been recorded to have more than 30 eruptions throughout the Holocene. Each of these eruptions have taken place every 1,000 of years or so. The last eruption of this fissure happened about 1,200 years ago. Compared to other volcanoes in Iceland, this volcano has been one of the most active. Based off of all this information, we're going to put together a hazard assessment for this volcanic system. The East Volcanic Zone in Iceland is very active and is the most active volcanic zone in Iceland. The Hekla volcano has shown to have very long and violent eruptions and is one of the most active volcanoes in Iceland. Vatnafjoll is also very active and has erupted every 1,000 years, the last eruption being about 1,000 years ago. Vatnafjoll tends to erupt evasively and not explosively. Geologists debate on the activeness of Vatnafjoll. Some say it's completely dormant and that the geologic activity is from surrounding volcanism, and others think that some of the geologic activity is related to the Vatnafjoll volcanism. This area is still on top of the spreading plate and in a volcanically active area. It hasn't erupted in 1,000 years, which means it might be coming up on its next eruption, so it's most likely starting to become active again. But it's hard to tell if it is for sure Vatnafjoll that is causing the small earthquakes in the area or the other volcanoes in the area. This all plays into the hazard assessment. Vatnafjoll is about due for another eruption, and it's hard to say what can occur from this eruption. Vatnafjoll is 4.2 miles away from Hekla, and they are part of the same system. If Vatnafjoll were to erupt, it's difficult to say if it would cause Hekla to erupt, but considering that Hekla is very active and also due for another big eruption, Vatnafjoll could easily affect Hekla. Hekla is very active, and any major geologic change in the area might cause an eruption. This is worrisome because of Hekla's very violent Plinian-type eruptions it has had in the past. Vatnafjoll is a 24-mile-long, 5-mile-wide fissure at an elevation of 4,052 feet. It produces very effusive lava flows, and when looking at the topography of the area, it looks like the lava flows could flow in all directions. It would probably mainly flow towards the west, where the topography drops to sea level. This is a more populated area of Iceland as well. Since the fissure is fairly large, a lot of material could flow in all directions. About 31 miles towards the west, there are a lot of major roads, cities, and towns. Basaltic lava flows from fissure eruptions can easily and quickly travel close to 20 miles away from the vent. This would destroy the houses and roads in the area. If Vatnafjoll were to erupt in colder seasons, lahars from snowmelt would cause major damage to the area and flood rivers, valleys, and towns. If this were to happen, flow from the eruption would reach further and possibly affect the more populated cities towards the west. If Vatnafjoll were to erupt and cause an eruption on Hekla, Hekla's glaciers and snows would also cause lahars. Hekla is not seismically active and only shows seismic activity about 30 minutes before the eruption. Hekla is a composite volcano and is very dangerous when it erupts. It tends to be very explosive, spewing a lot of ash 35 miles into the atmosphere at very high speeds. There are a lot of tours that happen throughout the day around Hekla, and although this area isn't highly populated, it is a popular travel destination. Because of all of this, a possible eruption of Hekla could be very dangerous. Based on the wind patterns, the ashfall from a Hekla eruption could reach hundreds of miles away and end up in the British Isles. It could also end up in Europe and Greenland. An eruption of this magnitude would most likely reach the highly populated region of Iceland towards the west as well. This would halt air travel and alter daily life. So based off of all this information, a final assessment of the volcanic system is going to be introduced. So based off of all the volcanic history for both Hekla and Vatnafjoll, an eruption today could cause a lot of damage to the surrounding area. These volcanoes are close to the populated region to the west, and based off of the topography, volcanic flows would most likely move in that direction by decreasing elevation. These volcanoes were studied together because they are part of the same system. Both of these volcanoes both have snow on top throughout the year, so a volcanic eruption would cause lahars and would flood nearby rivers and valleys. If Vatnafjoll were to erupt, there would be a low viscous lava flow that could travel for miles. If Vatnafjoll's eruption were to cause Hekla to erupt, Hekla would erupt violently, creating pyroclastic flows and spewing ash for hundreds of miles. Since Vatnafjoll erupts every 1,000 years, and it's been about 1,000 years since its last eruption, it is about due for another. Hekla is very active, and its last eruption was in early 2000, but it hasn't had a large-scale massive eruption in a while. Based off of all this information, an eruption from Vatnafjoll is a medium to high hazard, with high causing a massive Hekla eruption and medium having fast-flowing basaltic lavas and lahars, destroying houses and roads to the more populated west.